Hi everyone, Reddog here with a quick Houdini whiz through of the tools that I've made within Houdini Apprentice, which is the entirely free version of Houdini. It does have some limitations and some restrictions, but in the main they are able to be overcome through some creative Python script writing and workflows that kind of avoid doing things in inverted commas the easy way by just using nodes which would output things. You basically have to script outputs yourselves, but in the main it's a fantastic tool, and I'm really pleased that I started playing around with it, having resisted for quite a long time because I refuse to pay a lot of money to do what is essentially a hobby thing that doesn't in any way balance the scales in terms of its cost. So I thought I'd just give you a quick whiz through of what I've got. So at the minute it's structured mostly in the roads geometry object here. DEM import is a straightforward import of the DEM TIFF file. Rivers I'll quickly jump into because that does have some processing in it that's useful to kind of talk through. So I'm currently viewing the end node, but if I come up to kind of the start here, you can see there's nothing in the 3D view at all, apart from one point right in the middle, and that's because all the data is actually in here in the geometry spreadsheet. And this is because the very first node is a CSV output, and this is something I've got out of QGIS, and there's a variety of different things you can do in QGIS and different data sources and sets and so on, so I won't go through that in this video, but this is a series of data points that is coming out of my QGIS project for the area I'm interested in doing a map for. And as you can see, this data is all to do with rivers, and if I expand out, the WKT portion of it is a load of coordinates x, y, x, y, x, y of points on the map, which are rivers and these various streams and so on, and you've got a dam at one point as well. If we go back to the scene view, basically all of these nodes just take that data and then do things with it. So as I just step through, things change. So this is removing specific bits of the river system that I'm not interested in because they are either duplicates or they are branches of the river that I'm not bothered about. I could do that in QGIS, but it's as easy to do it here. And then this is setting an attribute of how wide the river is going to be, or creating the attribute rather. And then this is where the magic happens, if you like. This is parsing that data and creating geometry from it. So if I click that, I've suddenly got geometry everywhere. But as you can see, it's inverted, it's on its side, it's entirely wrong, so you've got to do a couple of transformation steps, do that, and suddenly you've got the data flat and it's lying where you want it. And then there's some admin keeping, really just doing some bits and pieces. And then this is basically generating is the data within a 6 kilometer block. So I've exported data based on a 8 kilometer square because I want to make a 4x map, and I want to have the borders to have the actual detail in. But actually I don't need a 2 kilometer river going out of view. And when you export the data from QGIS in the CSV, you can get data that's way outside of the area you're looking at. So this is just a way of trimming off down to a nice simple bit, and then I get an out, which is the imported curve, and that's basically where this project stops. And now if I go into if I switch on in here, this is a far more complicated set of data nodes. Each colour kind of represents different processing types. I've got a little explanation up here, but it's not complete. So grey is to do with the road data and getting the curves again brought in from QGIS data. Green is generating meshes that would be output into i3D format. Purple is to do with height field deformation changes. Yellow is a preview, so it's basically just for viewing. And then you've got red is for output processing for a few bits. The blue is for the rivers. And then this purple over here is for textures and foliage layers. And then there's some bits I'm working on over here, separate. So I'll just quickly run you through the road system. So again, the road system works very much like you've just seen the rivers. Gets to a point where you've got the curves imported, and I'll show that. So that's all the individual roads on the map in the area that we're interested in, and these are the roads on the 4x area. Great. Okay. If I zoom in, you can see I've got junctions. Well, we need to do special things with junctions because I want to create realistic geometry. So we have to isolate the junction points, and which are then, I mean, ignore the lines, but each of these dots is a junction, and then create these massive long cylinders, and they're used to cut apart the road network that we'd created before in order to generate here's the all the curves that we had imported with the area around the junctions deleted, and we do that specifically so that we can then come over here and generate the junction. So if I was to, for sake of argument, show that, there's just the junction geometry shown, and you've got the nice curves and the straight edges, and it all links up and so on. So you've got all of that. You've got road processing. So right at this stage, if I very quickly find the, where is it? The height field. There you go. That's the height field in, but you can see that I've already started smoothing where the road goes in that instance. It's easier to show in an earlier object. Yeah, that's the one I was looking for all along. So that's what it looks like as imported, and you can see the road is visible. You know where the road is, but you need to do some smoothing and what have you. And what the tool does is it takes a larger, wider area and smooths the edges so that everything. Originally, it was designed for the old style of roads where you had a mesh and it sat on the road, but it's perfect for the new decal system because everything's smoothed out for you. The other thing it does is find you bridges. So if we look at this node, for example, these are all areas where we've got intersections between where the road is and where the river is. So that's the river curve, and that's the road. And what that intersection is doing is saying those points basically need to form a bridge. And so we can create a data tag in the geometry spreadsheet which says, here we go, keep clicking the wrong thing, bridge ID. And so you can see we've actually found 33 lengths of road that need a bridge, as that data would suggest. That's a lot of bridges to model, by the way. curve correction. So this means that instead of laying the curve smooth to the terrain, for certain areas we actually need to make sure that the road doesn't dip into the river, because that's where the terrain is, right? What it needs to do is continue flat across the river. And again, that's kind of a holdover from the old needing a solid mesh, but actually for the bridges you'll need a solid mesh because the decals will run into the river, whereas you want the road to continue straight across. So you're going to have to split your mesh between the decal mesh and then the physical mesh, and if it all lines up, even better. And so all of this stuff is basically processing of the curves, and now we come onto the geometry, which I've shown you the basics of the intersection geometry, but here you've got the basics of the road geometry. So you've got a wide road continuing on here, but a side road, a narrower road is joining. And over here, if I just flick that on, you can see that between the two you've got a junction that's nicely formed like that. What I've been working on over the past few days is this, which is kind of automated white lines. So this is not entirely auto magical. I've had to do some manual processing in here, and at some point, if I ever get around to kind of finishing the tools and releasing them, it'll be very obvious which nodes you'll have to interact with yourself to get things to happen. But here you can see I've got a center line for the dotted line, and I've got two very wide external meshes which are going to be used for a solid line for the outside, but I also am thinking about using it as an additional decal layer to kind of merge the road into the terrain. So that's why it's quite so wide. It doesn't need to be that wide, but I've had an idea for dual purpose. And then obviously this road comes to a stop, and you need to have the dash, the junction white lines. I haven't even thought about trying to do that auto magically. This will be done in either Blender or GE using traditional modelling techniques, or just placing down some already made decals to do the actual junctions, because obviously the junction layouts are very variable, as opposed to using a road kit like you might see other people using. So if you want to see the whole thing sort of sat together, we can click on this, and unfortunately it takes quite a lot of time, because one of the things the river process does is it takes a look at where the curve is, which you've taken from your map, but what you'll find is the maps are never quite right, because the rivers meander and they move. So the process here is trying to find the logical point for the river to be based on the terrain you've got. So it's moving to the lowest point on the curve and then adjusting repeatedly until it gets to the bottom of the gully or the valley it's in, based on the terrain. And what you'll find is that doesn't necessarily reflect perfectly the reality of the river, but it's a good fit, I found, for the terrain that I'm using. So it works quite well, but as you can see, it takes 2,000 passes of the same process to get there. So we're nearly finished on that now, and puts a little debugging information, and boom, there we go. So now you've got the terrain I'm looking at, and I do like the way that Houdini works in terms of speed of being able to process this stuff. So this at the minute is all of my playable area plus my border terrain, and you can see where the roads kind of bleed into the borders, which is kind of useful because you want your borders to be almost indistinguishable from the playable area if you can manage it. And here you've got your river, and you can see it's carved its way through the valley quite successfully. There is very obviously a road here, or a path maybe, that I haven't got on my data, and that's probably because that road is classified as either a very likely it's either a footpath or a very low grade road, and so it's been excluded from my query in QGIS. But if you wanted to, you could absolutely run a road along it. You know, there's no issues doing that subsequently if you wanted to. So you've got your DEM, you've got your river, and my river, it's got a couple of junctions here. I haven't modelled the junctions like I do with the roads. They're individual planes, but they do match up quite well. They're not too bad, and you've got the road network all over there. So if I just template that very quickly, so it stays visible. If I come over here, I've got the cool stuff, which is the automated way of getting basic weight files to begin with. So I begin with a height field map of data from QGIS, and that is to contain the field information. So I've gone around, traced all the areas that I want fields, and I can visualize all these down here, hopefully. I've got fields, I've got trees, I've got so fields, roads, rivers, forests and grassland. And if I come down here, you can see the terrain is now coloured, and it's basically picking up this data. So the road mesh is being cast as an object, and a mask is being produced from that. And what that does is it generates a very thin band of area where the roads are. The same with the rivers, and that allows you to have, gravel maybe either side of your road. It allows you to have your river as mud, and your forest as forest, and your grass as grass, and all that sort of stuff. So if we come in here, at the minute I think I'm only showing one of the objects, but if I chuck in roads, now you can see the road layer is there, and you can see it's wider than the road, and that's because I've expanded the mask a little. So we'll have this as the river, and suddenly everything's blue. Well, that's clearly not the case. We'll have grass as green, that dark green. Yeah, something has gone wrong with that. Interesting. Yeah, let's get rid of that then. I find this node a little bit awkward sometimes. It does weird things. You see how it's just changed everything then? It's like it gets stuck in a rut of casting the colour. So now the river is blue, and the field areas have all gone this kind of default brown, which is what I wanted. So there you go. You can now see the playable area of the map, and these could all be exported as an image. And in fact, I've got a little button here that does that, export weight files. But that can then be used as the basis for mixing different textures together, because that would be a binary yes, no, on, off thing. And obviously, when you paint in GE a texture, say grass, you're actually getting a mix of 1, 2, 3, 4 texture colours coming through. So this is what some of the other elements in here do. So this takes the output that we're looking at and then uses it to generate some foliage masks, I think. So this Python node here is saying, right, in the area marked grass, I want a mix, and I want a mix of these specific RGB values, and these RGB values map to foliage types in your fruits density map. And what that's doing, the percentages there are really as an aid to the original version of this, but what you're actually doing is setting the values and the thresholds here based on how the mask interacts with almost a Doppler effect generated by a mask of pixel noise. It's a difficult thing to explain because I don't really know the right terms, but it's basically a random value between 0 and 1 that's mixed with a solid state to give variation. And what that then does is it breaks up an area into lots of different patterns, which you can then map your individual grass 1, grass 2, grass 3 colours to, or grass, bush, weed, etc., which is what this particular foliage is doing. And the same methodology then can be used to mix the output weight files. And again, I've got color coded stuff here, so the road is outputting a number of different colours. The river is outputting one colour. The forest is outputting a number of different colours, and they all go into these different weight files. And if I visualise this node instead, now you'll start to understand what I mean by if I look at the grass, you can see this speckled effect. That is because I've got grass 2, grass 1 and grass dirt patch as part of that grass layer. And that weight file is then created looking like this. You plug it straight into your map directory, load up the map, and lo and behold, it's pre-coloured for you, which I think is pretty bloody amazing, frankly. And then the other thing that this does, which takes a long time to cook through, so I won't bother, is it creates the border tiles for you. It will create 8 border tiles cut around your playable area of map. So the white bits here, obviously. So it'll create a tile there that's kind of that L shape, and then a rectangle, and then another L shape, then another rectangle, and so on. And it creates a high and a low poly so that you can bake the normals. That's the only bit I've so far had real trouble with doing, and have yet to come up with a satisfactory method of replicating what the paid for version can do very easily in a single node. Unfortunately, it probably needs a bit more explanation to me as to what the actual process is for me to work out how to create a Python node to do that. But hopefully that's been useful in terms of a quick overview of what is possible within Houdini in a single file, to go from almost blank map to certainly a almost plug and play starting point for a map that's already got basic things involved. Oh, there's one other thing I haven't shown, which is height field scatter. So if you want to, you've got your forest areas. If you want to have trees, you can use this, and it will place trees where the forest areas are marked on the map, and you'll get a load of individual XY coordinates that can then be used and exported into a CSV and imported into GE, and run a little script there, and it'll place a tree on each of these spots job done. So yeah, playable map from output from QGIS in, I would say, a couple of hours, when all's said and done, because there are some manual elements in here and you do have to do a little bit of correcting here and there, but generally speaking, yeah, it's pretty plug and play. Hope that's been helpful, and I'll catch you on the next one.